Hello guys, my name is Kenry Carty. Welcome back to my channel. Now today I'll be doing the second example of a trick proof. I did one already, so you can go and check that out. Now we have a proof here and we have two sides. So we want to prove that the left hand side is equivalent to the right hand side. Normally to construct a proof we have to take one side, and we can always try to take the more complex side and try to break it down to the simpler side. So I'm going to be taking the left hand side here. So I need to have a statement that says taking the left hand side, which is LHS. So we have 1 minus cosine A multiplied by 1 plus secant A. And in a scenario like this, it's always easier. Well, the simplest way we can construct this proof is just simply to take the more complex ratios and break them down into the simpler ratios. The simpler ratios are sine and cosine. So when I have secant here, we could recall that secant A is really 1 over the cosine of A. So we can change the secant of A to 1 over cosine A, which means this would become 1 minus cosine A, open bracket, 1 plus 1 over the cosine of A. Remember from my previous videos where we derived the identities, we said that the secant of A is 1 over the cosine A. Now we have two brackets to be expanded, so we're simply just going to expand them. So my first term here is 1. It's going to multiply everything in the second bracket, which is going to give me 1 plus 1 over the cosine of A. A similar concept will happen to negative cosine A. It will multiply everything in the second bracket. So I'm going to have negative cosine A. And of course, when I multiply negative cosine A now by 1 over the cosine of A, I'm going to get negative 1. Now look for the like terms here. We have 1 minus 1, that is going to give me 0, so that is gone. So what I will be left with here is 1 over cosine of A minus the cosine of A. We're not at our answer here looking at the right hand side, so we can go again and probably, since we have 1 over cosine A, we could put cosine A over 1 and write this as a fraction. So my LCM will be cosine of A. Cosine of A into cosine of A is 1. So I have 1 minus 1 into cosine A would give me cosine A. And then when I multiply that by the numerator, I'm going to get cosine squared A. Now this is beautiful because based on the trig identities that we derived, we can recall, so let me change the color here, recall 1 minus cosine squared A is equal to sine squared A. So I have, what I'm going to have here is sine squared A over the cosine of A. Now remember, I'm supposed to get sine A multiplied by tan A. So I'm going to have to do a bit of algebraic manipulation here. We know that sine squared A can actually be written as sine A times sine A. So I'm going to have sine A times sine A all over the cosine of A, which in this case I can actually separate this and say sine of A over the cosine of A times the sine of A. Good. Now we know that sine A over cosine A would give me the tangent of A. So I'm going to have tangent of A sine A. And of course, because multiplication is commutative, it doesn't matter which way I write it. Let us go back up and see what they have. So on the right hand side here, we have sine A tan A. That's not a problem. Alright, we can simply just write this as the sine of A times the tangent of A. And this is by the commutative property, which does apply to multiplication. Whenever we conclude a proof, we must have a concluding statement. So here I could say that the left hand side is equal to the right hand side QED. This tells me that the proof has been concluded and I've gotten what I'm supposed to get.